Guys, when we talk about multiplying with complex numbers, it's very important that you realize that when you multiply, you treat them like variables. So for instance, I always talk about the adding exponent rule that applies. So a to the second times a to the third equals a to the fifth. In this case, we're going to have 1i times 1i here. We're going to get negative 14 because negative 2 times 7 is negative 14. We got I to the second. I to the second, though, we can never leave it. We have to change it. And because of that, we're going to change it to negative 1. So negative 14 times negative 1 is positive 14. So we start. Negative 2 times 7i was the problem. We end up with 14. So as you go through these problems, you have to notice. So 7 times 3 is 21. And then I times I is negative I. So we end up with negative 21. 6 times 2 times 3 is negative 36, and then I times a positive 36, and then I times I is a negative I, so 36 times negative I is negative 36I. Then we moved on to the rule. You always have to take the I out first. So if you're ever solving one of these problems, so negative 5 times negative 20 is going to be take the I's out first. Take the I's out first, and you end up with negative 10. If you go too fast, you might accidentally eliminate the negatives, but you always take out the I first. Look at this one. We take the I out, take an I out. You get I squared, which becomes a negative 1. 3 times 18 becomes 54, and then you can reduce that all the way down to negative 3 radical 6. Same thing. We're still doing the four things you can do. You simplify radicals, you add radicals, you multiply radicals, and you can rationalize radicals. So next was a FOILing problem. So we have this times this times this, negative 30, and then this times this, and this times this, which gives us positive 10i minus 6i squared. But I squared gets removed. This has major repercussions later on. Because we can remove the I, we end up with negative 24, because negative 30 plus 6. Now let's talk about the repercussions. It means that when we go to do something such as rationalize, so for instance, here's our problem. Here's our example here. In this example, we have an I in the denominator. We do not have to eliminate everything. You do not have to eliminate everything, but because there is an I in the denominator, all you have to do to rationalize it is to multiply the top and the bottom by I. And once you multiply the top and the bottom by I, did that remove the denominator's 4i? Well, it did leave the 4, but it did make it into a negative 4, which got rid of the I. And that repercussions goes all the way to conjugates. So when we have to actually multiply something like 5 plus 3i, you have to multiply by the conjugate. So the original problem here, so we'll call this example 3. Over 5 plus 3i. We'll multiply the top and the bottom by the conjugate. If you remember the conjugate, you take the bottom and you exchange the plus with a minus. So remember all these, there's a lot of things to do, but it's still the same things you can do with radicals, you can do with I.